Hello and welcome to the wolfSSL live webinar, wolfEngine versus wolfProvider, presented by wolfSSL senior software developer Anthony. My name is Shizuka and I will be moderating this webinar. All attendees will be in listen-only mode. If you have a question, please use the Q&A box. We will host a Q&A session following the presentation. The webinar will also be recorded and made available on our YouTube channel shortly after the presentation. I invite you to follow us on Twitter at wolfSSL, as well as our other socials. Also, feel free to email us if you have any additional questions. And now, I would like to give a brief company overview before we move to the technical presentation. Today, wolfSSL secure over 2 billion connections. We have more than 1,000 OEM customers and dozens of resellers. wolfSSL is made up of over 50 dedicated employees, most of which are engineers. This progress is, of course, supported by a strong partner network that we are proud of. Since the beginning, our engineering team has developed several embedded security products, including wolfCrypt with DO178 support, FIPS certification, and a FIPS-ready offering, MQTT up to the V5 specification, SSH v2, TPM 2.0, a secure bootloader known as wolfboot, as well as Java wrapper and JSSC support, and commercial support for Core. All of these offerings are accompanied by through maintenance and support plans up to the 24/7 level. We also offer full service consulting. And now I'd like to turn it over to Anthony to talk about wolfEngine versus wolfProvider.
Thank you very much, Shizuka. Let's see, I'm going to move on to the title slide here, if I can just sort of figure that out. There we go. So my name is Anthony Hugh. I've been working with wolfSSL for over 2 years now, probably close to 3. I'm a senior software engineer here, and I do coding development as well as talk about some of our technology on webinars. So today we'll be talking about wolfEngine and wolfProvider. To just a little bit of housekeeping here. I'm currently under the weather and have a bit of respiratory ailment, so you might hear me coughing and sneezing every once in a while. But there's a good example of it. So my apologies for those audio interruptions every once in a while. Okay, so let's get started. Here's the agenda for today. We're going to be talking about, first of all, the compatibility layer, which is, something that kind of, I wouldn't say competes, but is a nice alternative instead of using the engine or the provider. Then we're going to be talking about OpenSSL and the various release branches, and talking about, what they are and some of their history. We're going to be determining which branches are suitable for engines and providers, so you can easily figure out whether you need a wolfEngine or wolfProvider. We'll be utilizing, we're going to look at how you utilize a wolfEngine and wolfProvider in the OpenSSL application. So if you understand how OpenSSL exists, it's both as a library that you can build your applications against, but there's also an OpenSSL applications provided with the OpenSSL source bundle. And so a lot of distributions already have the OpenSSL app pre-installed. So this is we're going to talk about how you can use the provider and the engine with that. We're going to be going into how to integrate wolfEngine and wolfProvider with the OpenSSL API, so how you would use it in your own applications that build against OpenSSL. We're going to be talking about the available algorithms and cryptographic primitives that we implement in the engine, and and finally we're going to go in a little bit and talk about FIPS and FIPS compliance. And let's be perfectly honest, one of the major reasons why people want to use wolfEngine and wolfProvider is because of FIPS. So we'll be talking a little bit about that at the end. Yep, hold on. There we go. So, okay, let's get into the compatibility layer first. So when you're using the wolfSSL's OpenSSL compatibility layer, you literally just do this. You build it, you configure it with enable OpenSSL all. You do a make all and a make check, and you do a sudo make install, and that gets everything in place. The sudo ld config might not be needed, depending on whether how your system works, but we throw it in there just to make sure that people do it just in case their system does need it. And so it's really as simple as that. And once you have that done, your application code will look like this. Oh, oops, I left in a wolf TLS 1.2. So that wolf there, in that's a mistake. You don't actually need to have the wolf TLS v12 server method. If you just use TLS v12 server method, that'll be perfectly fine. We have macros that are in our headers that kind of transform your code into wolfSSL APIs. So when you're using code when you're using the wolfSSL's OpenSSL compatibility layer, you will not need to change any of your code. Your code will look exactly the same. What you will need to do is kind of change your build options. So for example, for linking, normally you do -l crypto -l SSL. But instead, what you're going to be doing is, pointing to a different include location and pointing to a different linking location, and you'll be, -l wolfSSL instead of those two libraries. And let's be honest, the one thing that everybody knows about wolfSSL is that we have the greatest support. So if you have any problems at all, even if you're not yet a customer, if you're just experimenting, we'd love to hear from you, and we'd love to hear where your pain points are using our stuff. So, give us a mail at support@wolfssl.com if you find any problems with our compatibility layer, OpenSSL compatibility layer, sorry. So that I wanted to talk about the OpenSSL compatibility layer because it's an alternative to the wolfEngine and wolfProvider. But now let's talk about OpenSSL's various release branches. So, before, a lot of people know that OpenSSL has a very long and storied history. From my own personal experience, the first release branch of OpenSSL that I used was 0.9.7, I think. But generally speaking, nobody uses anything that old anymore. It's very, 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 it's almost antique source code, you might even say. And even the 1.0.2 release branch is considered old. Its main feature is that it has TLS 1.2 and other earlier protocols. Again, it's very, very old. It's no longer updated by the OpenSSL team. So generally speaking, even they say, please don't use the 1.0.2 branch. But yeah, generally speaking, this is the oldest thing you'll see in the wild these days. You won't see anything older than the 1.0.2 stuff. So if you're looking at the 1.1.1 release series, that introduced TLS 1.3. It also added the twisted Edwards curves for ECC. So things like ED448, ED25519, X448 for key exchange, and X25519 for key exchange as well. Those got integrated into TLS 1.3, so those all got supported. And yeah, the big news for 1.1.1 was TLS 1.3. Again, it's old. It's actually more common to see it out there though, but it's no longer being updated by OpenSSL either. So it's I wouldn't, it not only is it not supported, it's not updated at all. So it's suggested that this is not, but it's suggested by the OpenSSL team to not use this as well, if you look on their website. But it is still quite commonly used out there. So now we come to the 3.x.y series of branches, and this is the newest series of branches. And the big news in these branches is that they introduce what's called the provider. The provider is, if you're familiar with the engine, it's the new version. It's the new kind of interface for replacing the engine in the 3.x.y series. So the 3.x.y series supports, public key algorithm implementations and definitions in the providers. Excuse me. So what's really interesting about a provider now is that even algorithms that OpenSSL didn't know about, or doesn't know about, or doesn't care about, can be supported in the OpenSSL library if the implementation and definition of those algorithms is in a provider. So what does that mean? It means for things like post-quantum algorithms, which are not yet standardized and so probably are not supported yet. Within OpenSSL, they're not supported at all. Someone can go in and kind of define and implement the algorithms and kind of get them into get OpenSSL to use them, even though OpenSSL is not aware of them at all. One of the big headaches and pain points about the move to 3.x.y is that there's no backwards compatibility. If you have an application that was built against any previous version of OpenSSL, you're going to have to go and reference OpenSSL's migration guide. So there is no like compatibility, header files between 1.1.1 and 3.x.y. What you have to do is you have to go and download their compatibility layer document. Sorry, not their compatibility layer, their migration document, and kind of slowly go through your whole application trying to figure out what new APIs you need to use and how to kind of get around the changes. It's quite a challenge. I've been through that work. Again, this is the newest set of branches. It's still being updated, obviously, and it's under active development by the OpenSSL team. Okay, so now we get into how you choose wolfEngine versus wolfProvider, and it's quite simple, but I'm still going to talk a little bit about it. It's a really simple algorithm. If you have OpenSSL, then even if you've installed OpenSSL, sorry, then automatically the installation will also install the OpenSSL application. And so from your shell, you just type OpenSSL space version, and that'll output the current version of OpenSSL that you're using, whether you built it yourself or whether it came with the operating system that you're using. Now, the algorithm is basically as simple as if you see 3 dot something, then you need wolfProvider. Any other version, then you need wolfEngine. So providers are from 3 up, and engines are anything before 3. Right. So next we're going to be talking about how you use wolfEngine and wolfProvider with the OpenSSL application. So when you download wolfEngine, you download a source bundle. Inside that source archive. And so inside that source archive is something called an engine.conf file. And you set an environment variable called OpenSSL conf to point to that file. in your file system. And then when you run the OpenSSL command line, you do all your other stuff. Like, for example, maybe you're trying to run the X509 command. So it'd be OpenSSL space X509 and then dash engine wolfEngine. And then whatever other parameters that you would want to add to that command line, push enter. And instead of using OpenSSL's implementation of the algorithms, you'd be using our implementation, which is wolfEngine, but that's also then under the hood calling into wolfSSL. So you'd actually be using wolfSSL's implementations of those algorithms. Now that's for the engine. For the provider, it's actually even simpler. What you do, you don't need to worry about the conf file. You just add dash provider dash path, and then the path, the absolute path to the wolfProvider library file, and then you do dash provider with wolfprov, and there you go. It's as simple as that, and that will then use wolfProvider again, which then calls into wolfSSL, which is how you which is then using wolfSSL's implementations of all the algorithms. And now we talk about how to use them in your own applications when you're building against OpenSSL. So again, in this case, you set the environment variable OpenSSL underscore engines to point to the directory containing your engine build product, wolfEngine build product, which is libwolfengine.so. And then in your code, you simply add the following and near the beginning before you use any wolfSSL functions. Sorry, not wolfSSL, OpenSSL functions. And this will basically tell OpenSSL to override all implementations within OpenSSL with wolfEngine. And again, wolfEngine will then call into wolfSSL. So you'll be using wolfSSL implementations of algorithms. And here's the code for adding it for provider. And it's quite simple. I mean, I'm kind of sounding like a broken record here, where we talk about just getting things overridden, but it's just 4 lines of code. Now, obviously, let me back up to the previous one as well. This is just 2 lines of code, but that's for brevity. Obviously, you're going to want to check if wolfEngine, the result of this call, if wolfEngine, the pointer is null or not. You should always be checking for your return values. Again, these ones, this is 4 lines. Oh, no, it's 3 lines of code. One of them is too long, sorry. So it's quite simple, but again, you need to be checking for your return values. WP lib context could actually be null. The return code for the return of OSSL provider load might also be null. So WP prov might be null. So you need to, you'll need to check and make sure that these things actually return are returning proper things and not having any kind of errors. And that's just best practices. This, of course, is a presentation. So for the sake of brevity, we don't add that code here. And again, this will tell OpenSSL to not use their own implementations and to override their implementations with those of wolfProvider, which will then obviously call into wolfSSL. Wow, that was fast. So now we're going to go into the algorithms and primitives that we make available through wolfProvider and wolfEngine. I'm going to start with wolfEngine because it's a smaller set. So yeah, we provide all of these, and all of them can be configured to be enabled or disabled. So For example, MD5, I'm pretty sure there's a good chance that you're not going to want to be using MD5, so you can disable it. It's there because it's in OpenSSL. But if you want to, you can disable it. Same with DES3, maybe not enabling it would be a good idea. There's one that's really interesting and that I've highlighted in red, which is curve P192. And it's not in red because we don't support it. We do support it, and it's there, and it's built by default. But I put it in red there because there are in the wild some implementations of there are some versions of OpenSSL that are built without P192 being enabled. And that's actually a FIPS requirement because it's the key sizes are too small for FIPS. And so you'll find some OpenSSL versions don't have support for P192. And so if you build wolfSSL and wolfEngine with P192, it's actually going to cause an error when you do our unit tests, because our unit tests expect P192 to be enabled in OpenSSL. So it's kind of a small gotcha that I thought I'd go over and talk to you guys about. Make sure that you understand that if your OpenSSL implementation does not have a P192 ECC curve enabled, then you'll need to also disable that in your build of OpenSSL in your build of wolfSSL and wolfEngine. Okay, so wolfProvider has everything from wolfEngine as well as SHA-256, SHA-512/224 and 256, and GMAC and PKCS12 PBKDF2. So why are these added in wolfProvider? Well, wolfSSL has support for all of these as well. It's just that in the OpenSSL 1.1.1 releases did not have these support for these. So since the three OpenSSL 3 branches do have support for these, we decided to also add them into support for wolfProvider. And so yeah, this is SHA-512/224 and SHA-512/256 are just like SHA-512, except the initial states, it starts out with a different initial state and it truncates the output. And so it's basically just SHA-512 for applications that don't need such a big hash value. And so yeah, there we go. And so just a little bit of a talking point about FIPS. There are some of you, some people in this watching this presentation who might genuinely be curious about engines and providers and didn't know this, but for the most part, most people use engines, a wolfEngine and wolfProvider, because they know that we are diligently we are very diligent about our FIPS certification. So for FIPS 140-2, we have our certificate 3389. And that's been going strong for a nice long time. For 140-3, we are on the cusp, on the very final stages of getting our 140-3 certification. Now, the big question for most people that are using OpenSSL on the 3.x branch is, when will OpenSSL get its FIPS certification for its providers? And the answer is it actually, this isn't from me. This is not me making anything up. You can actually go to this blog post that I've listed right above, and you can look at it. And they are on the IUT list, which is the implementation under test list. So there are various stages in getting your FIPS certification, and I'm by no means wolfSSL's FIPS expert. We have many presentations. In fact, I think just a couple weeks ago, my colleague Caleb Himes had a FIPS webinar about our progress going through the FIPS 140-3 certification process. And just to get you an idea, when they say they're on the IUT implementation, when they say they just got on the IUT list in 2023, October 2023, we were there since September 2020. So just to give you an idea of what they're going to have to go through in terms of a timeline, this is the process that we've run through for going through FIPS 140-3. So when will they get theirs? I'm not really sure, but they're probably going to have to go through a very similar process of of all these steps, right? Like going through the MIP list, going through various audit steps, various changes, requests, talking to the CMVP, writing up various documents and documentation. So when they'll get it, we're not sure. But that's why a lot of people really look to us, because they know that we're going to have our FIPS 140-3 certification any moment now. And that certification will apply to both wolfEngine and wolfProvider. So if you're still on like the 1.1.1 branch and you're looking and you're wondering, how are we going to get FIPS 140-3? Well, you can talk to us and we can help you out there. And that's the end of my presentation. So I'll hand it back to Shizuko, who will moderate the Q&A session.
Thank you, Anthony. There is a question. How long will OpenSSL 3 branches be supported?
So if you look on their website, on their when their releases website, I think they have a download. On OpenSSL.org, they have a downloads page where you can download it. On that page, they also list the lifetimes and the end of life of each of their supported branches. And so the longest LTS branch will be supported until September 2026.
Okay. There is another question. How old is OpenSSL 3?
So basically, once OpenSSL was stabilized their TLS 1.3 implementation, they started work on their 3.0 branch. And so that kind of was born with the first release of, the first official release of the three branch was in April 2020. So that's about 3 years old now, a bit more than 3.5 years old now.
Okay. Another question. It is easy to move from OpenSSL 1.1.1 to OpenSSL 3.
No, I kind of alluded to this during my presentation, but there's no API compatibility. So because of that, they have a migration guide, and so you need to go and read it. It's a big long PDF document. I don't know how many pages it is. I've read it though, and it's a little bit of a painful process. If you're using engines, it's gonna be a nightmare, because those engines are, you have to move to the provider system. So it is not a simple process. It is a kind of it's basically something, if you're running in an agile mode, you're probably going to want to have like a whole system set up for a whole different swim lane set up for this effort.
Okay. There is another question. How does OpenSSL 3 and a wolfProvider integrate with Python and Python modules that rely on TLS slash other encryption functions such as URL library 3?
I would imagine that all you have to do is set up the right APIs. Actually, I'm not very familiar with the Python stuff. As long as they support the provider paradigm, you might say, then and they must, because actually OpenSSL's own implementations are providers. But they need to be able, but the Python system needs to be able to change the providers. So as long as they call in, they have those, sorry, they are aware of those APIs, then it should just seamlessly go in and it should just be fine. That said, I don't have that much experience with using Python with OpenSSL 3.
I have another question. If you want just one algorithm and then key types, can you build to remove the list and make a smaller libraries?
So you're asking about wolfSSL, and if you are asking about wolfSSL, the answer is yes. If you are looking for a smaller binary for wolfSSL, you can build wolfSSL such that you turn off all of TLS, all of SSL, and so there's no protocol layer on top. You can then have like which will make the wolfSSL library smaller, and then you can eliminate any algorithms you're not looking to use. So for example, if you don't really care about RSA and you want to focus on ECC, you can actually disable RSA. And so that will take out a huge amount of code within wolfSSL. And then that can get reflected in the engine or provider, which will also decrease in size. And then what will happen then is that, yeah, wolfSSL and wolfProvider will be small, or wolfSSL and wolfEngine or wolfProvider will all be smaller. Unfortunately, that's not the case for OpenSSL. I don't think you can turn off algorithms in OpenSSL. I think they all have to be enabled.
If there is not any more question, I will close the Q&A, and thank you, Anthony, for hosting an informative webinar and everyone for joining the webinar today. Please don't forget to follow us on Twitter at wolfSSL, as well as other socials. And if you have a question, please email us to facts@wolfSSL.com. And thank you again, and see you next week.